Subtopic 4.1 Ionic Bonds. Let's get sticky. Ionic bonding is the electrostatic attraction between ions of opposite charge. And the classic example is chlorine and sodium. Chlorine is far more electronegative than sodium, so it pulls an electron right off of it. Of course, now, from the gain and loss of an electron, they are both charged ions. And it's this charge difference that forms the ionic bond between them, and it's a rather strong bond, actually. But even in this case, there's a limit. Now we need to learn some commonly formed ions, and we'll go to the periodic table. In group 1, all the elements readily lose one electron and form a 1 plus cation. Their neighbors in group 2 can lose 2 electrons and form a 2 plus cation. This pattern continues in group 3. However, by group 4, the pattern breaks down because losing 4 electrons is rather expensive in terms of energy terms, and they don't profit if they were to lose 4 and then make an ionic compound. However, in group 5, the trend continues, but in reverse, because these elements can readily gain 3 electrons and form a 3 minus anion. Group 6 and group 7 continue the pattern as we would expect, and of course, the noble gases don't want to gain or lose any electrons. We also need to consider the transition and post-transition metals. Now with these, it's much harder to predict what ion they will form, but we still need to learn some common examples. Iron can form 2 different cations, a 2 plus and a 3 plus, and they look different colors in solution. Copper also makes 2 different cations, and they look different colors in solution. Lead only makes a 2 plus, and tin will form 2 different cations, and silver likes to form a plus 1 cation. Hydrogen forms a plus 1. It should be expected that it can lose 1 electron, and it can also gain 1 electron and form an H minus ion. Writing the formulas of ionic compounds is pretty straightforward. We've already seen sodium chloride. Notice that they form in a 1-to-1 ratio, so that there is a neutral charge overall. The same thing applies to magnesium and oxygen. If we reference a periodic table, we know that magnesium makes a 2 plus cation and oxygen makes a 2 minus anion. Therefore, they also form a 1-to-1 compound. Magnesium and fluorine, though, don't form 1-to-1. Because while magnesium is a 2 plus cation, fluorine is a 1 minus anion, and therefore they form in a 1-to-2 ratio when they make an ionic compound. In order for 2 elements to form an ionic compound, they need to have very different tendencies to lose or gain electrons. The measure of this tendency to lose or gain an electron is an element's electronegativity. We can also just look at the position of 2 candidate elements in the periodic table. We can do this because of the trends in electronegativity across the periodic table. And as you can see, most commonly ionic compounds are formed from a metal and a nonmetal. Polyatomic ions are formed from more than one atom. And there's a short list of them that we have to memorize for the IB test. They're all listed in your book, and I'm showing them here. I'll just briefly mention that many of them are anions, and they all combine with a metal cation to form an ionic compound. This last one, of course, is a cation, and it is the conjugate acid of ammonia, a common base. Ionic compounds don't form molecules technically. What they do is squish together like marbles and form a lattice, where we write the formula for the ionic compound from its base unit, sodium chloride, 1-to-1 ratio of each. If you look at the lattice, you can't really say where one molecule of salt begins and ends. It's all one big continuous structure. This is similar to metals. The end. Thank you.